Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 1 to 5 of the August 2016 Algebra 1 Common Core New York Regents exam. If you have any questions at any point in time during this presentation, just place your questions in the comment section below, and we'll be more than glad to support you. All right, let's take a look at question number 1. It says the graph below shows the distance in miles m hiked from a camp in hours h. Okay, so the x-axis is hours h, and the y-axis is basically miles traveled m. Question: which interval has the greatest rate of change? Okay, so one thing you want to recall is what that term rate of change means. Okay, so you want to recall that rate of change is the same thing as what? Rate of change is the same thing as your slope. Okay, and how do you compute your slope? Your slope m is rise over run using your slope triangles. If you want to use the coordinate approach, is y2 minus y1 over x2 minus x1. All right, for the sake of time, we can use the rise over run approach here since our points fall nicely on the lattice points of our coordinate system. Okay, so we have 4 intervals that we're going to be looking at here. So to help make the process easy to compute, we're going to label our intervals. From 0 to 1, that's interval 1. From 1 to 2, interval 2. From 3 to 4, interval 3. So we have 0, 1, 1, 2, 2, 3, and 3, 4, interval 4. Okay, take a look at interval 5 for a second. You have no rise there. Okay, so the rate of change in this interval is 0. Okay, so these are the ones that we're comparing. Now, if you take a look at them just by inspection alone, the steeper the line is, the closer it is to the vertical. Okay, so which of the lines is closest to a vertical line going up or down? Okay, so this is the highest slope you can attain. This is the smallest slope you can attain if you're just looking at positive numbers. Okay, so the closer you get to the vertical, the bigger your slope becomes. All right, so if you look at all these, you can clearly see by inspection that the first interval has the biggest slope or the greatest rate of change. All right, but let's go ahead and work out the process. We need to know for certainty that this interval has the greatest rate of change. Okay, so what we're going to do is just find the slope of each interval. Let's start with interval number 1, which is from 0 to 1. Now, what is the slope there? The slope is rise over run. All right, so to help you do this, just draw your slope triangle on the graph. So we're just gonna rise. Let me do this. You're gonna rise green color. You're gonna rise 2, and you're gonna run 1. Okay, so your slope there is a rise of 2 and a run of 1. So your slope is 2. What does that mean? That means that your rate of change on that interval is 2. Proceed to interval 2, which is from, what is that, 1 to 2. So from 1 to 2, we want to compute the slope. So the slope is going to be rise over run, same formula. Slope is rise over run. So your rise, let's put in our slope triangle there again. Okay, so let's see. Okay, so we're going to be rising. We're going from this point to this point. Okay, so we're gonna rise that amount and then run that amount. So we're going from this point from 1 to 2 as indicated here. So when you go from 2 to 3.5, what on earth is that? From 2 to 3.5, 3.5 minus 2 is 1.5. So you're going up 1.5. All right, so your rise is 1.5 and your run is the same length as interval 1, which is 1. 1.5 over 1 is just 1.5. So our rate of change on that interval is 1.5. Okay, so you see what's happening. As it gets less vertical, approaching the horizontal, the rate of change is decreasing. All right, what do you think is going to be with 3? It's going to be less, right? Because it's less vertical. So let's make sure that our hypothesis is correct. For interval number 3, we are going from 2 to 3. What are we looking for? Slope or rate of change, which is rise over run. All right, let's take a look at the graph. On that interval, I'm going to use a different color. We're going to rise 1. Remember, you got to be careful with the axis, okay? Because 2 boxes count for 1, so be careful with that. So 2 boxes rise 1, you run 2 boxes 1. So this one you're rising 1 and you're running 1. So the slope for interval 2, 3 is 1 over 1, which is 1. So what's your rate of change here? It's the same as the slope, which is 1 also. Okay? All right, last interval is interval 4. We're going from 3 to 4. All right? So for interval 4, we're going from 3 to 4. And remember, your rate of change is your slope. So your slope is rise over run. So by how much are you rising and by how much are you running? So let's go ahead and do that. Let me make it blue this time. So you're gonna rise just 1 box, which is equivalent to 0.5 or a half, and you're running 2 boxes, which is equivalent to 1. All right, so 1/2 over 0.5 over 1. So our slope is going to be 0.5 over 1, which is 0.5. So that tells me that the rate of change is 0.5. Okay, so compare all these values. 0.51, 1.522 is the greatest. Okay, so the greatest rate of change is 2. Okay, on the interval 0 to 1. So answer to number 1 is option number 1. Okay. All right, let's take a look at question 2. It says the solutions of an equation with variables x, y is. So question number 2 is assessing your understanding of the term solutions. What does it mean to have a solution to an equation? Well, let's go over the meanings of these 4 remarks because there is important that you know what each and every one of these mean for much more advanced mathematics classes, okay? All right, first one, the set of all x values that make y 0. So anything that makes y 0 is known as your x-intercepts, okay? So these are known as your x-intercepts, okay? Now, this could be a solution sometimes, not always, okay? It could be a solution to a quadratic equation, not an equation in terms of x and y. Quadratic equation is just in terms of x, but this has x and y, so you gotta be careful there, okay? 2, the set of all y values that make x equals 0. What is this called? This is called your y-intercepts. Y-intercepts. All right? The set of all ordered pairs x, y that make the equation true. Solution true. They mean exactly the same thing, okay? Whatever makes an equation true is known as the solution. So this is exactly what we're looking for. This is always the solution to an equation in terms of x and y, okay? All right, option 4, set of all ordered pairs where the graph of the equation crosses the y-axis. What is that called? That is also called your y-intercept. Okay? Y-intercept, where the graph crosses the y-axis. Now, where the graph crosses the y-axis, guess what? At this particular point, x is equal to 0. And it's the same case as option number 2. When x is 0, the graph crosses the y-axis and you have a y-intercept, okay? So these 1, 2, and 4 are intercepts. Number 3 is exactly what we're looking for, the solution, which is what makes an equation true. All right, let's take a look at question number 3. It says, which statistic cannot be determined from a box plot representing the scores of on a math test in Ms. DeRuyter's algebra class? Okay, so what can a box plot not tell us? That's what this question is asking. So not, that's what we're looking for. So in order to answer this question, we're just going to sketch a random box plot and see what it tells us. Okay, so whatever is missing, that's going to be the answer to the question. All right, so there goes the box plot for you. So it takes you to the maximum, takes you to the minimum, and then you have your median right there, Q2. Okay, so this is your nice little box plot. Let's go ahead and label it. Okay, so see, this right here, this is your minimum. Okay, that's your minimum. This value right here, that is known as your first quartile, Q1. Okay, and this in the center right here is Q2. All right, this is your second quartile, known as a median. What is this one right here? Q1, 2, as you might expect, this is Q3, your third quartile. And lastly, we have our maximum. Okay. All right. So let's see. The lowest score is the minimum. Does this graph tell us the minimum? Absolutely. So your lowest score is the minimum. So check. That's what the minimum is. The median score. Does this tell us the median score? Absolutely. Your median score is your change the color, is your second quartile. That's your median. All right, so the box plot tells us that value. 3, highest score. Does this box plot tell us the highest score? Guess what? Your maximum is your highest score. That's your maximum. And it clearly shows that to us. By method of elimination, we can automatically conclude that option 4 is the correct answer. But let's consider what it is. It says the score that occurs most frequently. Let's take that out. Okay, so what occurs most frequently? All right, so this graph does not show us what occurs most frequently. Okay, so the correct answer is option number 4. Okay, let's take a look at question 4. It says, which chart could represent the function f of x equals negative 2x plus 6? Okay, now there are different strategies you can use for this problem. First of all, if you take a look at the slope, it has a negative slope. So what does that tell you will be happening with the function? So this is a tip. Functions, that's linear functions, okay? With negative slopes, slopes are decreasing functions, okay? They're decreasing functions. So our output should be decreasing, okay? So if you take a look at the options 1, 2, 3, 4, look at the outputs. What on earth is the output? I'm talking about f of x. Take a look at the f of x values. Which ones are going down? 6, 10, that's going up an increment of 2. 4, 6, that's going up by an increment of 2. So this is plus 2. This is plus 4. 8 to 10, that's an increment of 2. 6 to 4, that's a reduction of 4. So based on that and that alone, we can automatically see that the answer is option 4 because that is the only function that's decreasing. Okay, so that's a neat little shortcut you can use. The other ones are increasing, so they are wrong. Another way you can do this is by picking ordered pairs and testing this function with that. Okay, so let's go ahead and try it. All right, so when testing values, one neat little trick you might want to keep in mind is that when test makers are making multiple choice tables like this, they like to create values that overlap. Okay, so for example, if you look at 1 and 4, 0, 6 and 0, 6 are identical. So it makes it more difficult for you to determine which one is the correct answer. So in most cases, skip the first two and go right to the third one. Or you can start from the last values and work your way up. Okay, so I'm going to test um, x equals 4. All right. So what do I mean by testing x equals 4? On all four tables, I'm going to plug in 4 into this function right here, and then I'm going to see what output it generates. Okay, so whichever output matches these ones right here, that will be the correct answer. So if I get 14, option 1 is correct. If I get 12, option 3 is correct. If I get 8, option 2, and then negative 2, option 4. Okay, so we have f of x equals negative 2x plus 6. So I'm evaluating the function at x equals 4. All right, so if we do that, we're going to have negative 2 times 4 plus 6. Using your order of operations, you multiply first, right? Please excuse my de-tally. Multiply, you have negative 8 plus 6. Final answer is negative 2. So whichever one has the ordered pair 4 comma negative 2, that is the correct answer. And as you can clearly see, option 4 is correct. So that's just another way of doing it. Another way you can do it is by using your calculators. Just use it to generate input-output tables. So let me show you how to do that if you don't want to do anything by hand. So go to your Y window, enter the function negative 2x plus 6. Now this is the deal. We're going to be going to the table, but we want to tell the table what to compute. So to make that alteration, press second function window that takes you to the table setup. Under independent or the X, you switch to ask, not auto. Okay, what this does is that the calculator asks you for the input you want to calculate the output for, as opposed to starting at 0 and then going 1 unit higher for every single row. Okay, so let's go to the table. So let's just test 0. So press 0, enter, bam, 0, 6. So we see 0 option 1 or 4. And I enter 2, enter 2, 2, bam. Option 4 is the correct one. 4, you see how fast it is? Okay, so don't forget to set it to ask for your table setup so you can compute the specific input output values that you desire. And as you can clearly see, our answer is option number 4. All right, let's take a look at question 5. It says if f of n is equal to the quantity n minus 1 squared plus 3n, which statement is true? All right, there are two ways of doing this. You can do this with your calculator, which is really fast, or you can do it by hand. Okay, so I'm going to show you how to do it by hand first. All right, method 1 is your basically manual computation. Now, in higher level math classes like AP Calculus, for example, sometimes you're not allowed to use a calculator, so you need to get your algebraic skills up. Okay, you don't always want to be dependent on the calculator. Okay, so what we're going to be doing here is plugging in the specified input values and see which one generates an output that matches one of these options right here. Okay, so we're using the same function. Let's go ahead and get started. So for option 1, we want to evaluate the function at x equals 3. Okay, so what does that mean? Just plug in 3 in the end. So you have 3 minus 1 square plus 3 times 3. Okay, 3 minus 1 is 2. 2 squared plus 3 times 3 is 9. So you have 2 squared, which is 4. 4 plus 9 is 13. As you can see, option number 1 is false. An interesting thing that I found out is that some students are much faster computing, manipulating numbers by hand than people are with entering it in the calculator. Okay, so if you're that student, don't waste your time, just do it by hand real quick. All right, so negative 2 minus 1, quantity squared, plus 3 times negative 2. All right, and then you have negative 2 minus 1, add and keep the sign, negative 3 squared, positive 3 times negative 2. Signs are different, so it's going to be minus 3 times 2 is 6. Now here you want to be careful, okay? Negative 3 squared, the sign changes to positive 9. 9 minus 6, okay? 9 minus 6 is 3. So that matches. F of negative 2 equals 3. This is our correct answer, option number 2. Now, if you're nervous or not too confident in your arithmetic skills, you can use your calculator. So we're just going to do it as we did number 4, okay? So we have parentheses x minus 1 square. Now, the independent variable for the calculator is x, okay? So whenever you have a variable that you're plugging into the calculator, you switch it to x as your independent variable, all right? So this is n minus 1 square, but we're just using x because that's the fixed independent variable for the calculator, okay? Plus 3x, enter. So there goes your graph, the function. We're going to go to the table. Look at the setup. We set it to ask. What does that mean? It means that it asks you for the input value you want to calculate the output value for. If you don't tell it to ask, what's going to happen is that it will automatically generate values based on the start and the change delta values, okay? So for option 1, 3, press enter, 13. That is not what we want. If it were 13, then this would be the answer, but it's not, so option 1 is wrong. 2, enter, oh wait, sorry. For option 2, we're entering negative 2. Enter 3, that's exactly what we want. Let's just enter these two just for fun, okay? Just to show that they're wrong. Negative 2, well, we already did negative 2. Negative 15, bam. 211, and that's not equal to negative 2, so we can clearly see that option 4 is wrong. So with your calculator, you can easily determine the correct ordered pair that this equation satisfies, okay? Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your review for the New York Regents Algebra 1 Common Core, to give us a thumbs up. Your positive feedback is very important and supportive to us. Questions and comments should be placed in the comment section below. We're still working on the remainder of this review series, so don't forget to subscribe so you can get updates to those. More clips can be found on math.serve.com under New York Regents. Thanks again for watching and have a wonderful day.